Friends, this is a recording on using on writing a program and software to do quadrature encoder counting on an optical incremental encoder. To get started, let's look at our hardware setup. I have it right here. Take a look at. I've got sorry for all this. Okay, we've got our we've looked at this little setup before. We've got a brush DC motor. You can see I've got my two leads going to the brushes. There's an encoder on the back that's not being used. Underneath, there's this clean little belt drive. And we have an encoder where? We've got an encoder on this side. Right here, we have an encoder. It's a pass-through hub running out to this little turntable. The turntable gives us a little mass. I think there's like a 3-to-1, 4-to-1 gear reduction. So just the motor is driving this guy. So for this lab, I'm just interested in the quadrature encoder that's under here. So that's where we'll spend our time. Coming out of the encoder, the encoder that leads come here. There are 4 leads that I've pulled off. Typically, these typical optical encoders have 5. This one I'm using 4. See in my drawing, but here orange is going to be this kind of standard. Orange is my 5 volts. Brown is my ground, and then my 2 output signals, channel A and B, are yellow and blue. There's sometimes another lead coming out that's single pulse per count. Okay, and then I have, if you notice, I've hooked that up to my app Mega. We'll talk about the details here. So we've got the color arrangement, and then I've got my scope connected. So the first thing we're going to do is, can't see. Oh yeah, there it is. My 2 scope leads. So channel A and B hooked up. So now I'm going to zoom you over to the scope. Let's just take a look and see what happens. Can't really see me. Can you see me rotating in the scope? I don't think you can see me rotating in the scope. Okay, so look at the scope there. There you get the scope. If I put that in the way, you can't see me. Okay, so I'm taking my hand and I'm rotating the turntable. So I'm rotating it clockwise as I look down on the table, and you can see that I'm getting pulses. So what am I seeing here? Well, I'm seeing, we'll say channel A on top, then channel B on bottom, and I'm just going to run them at a nice regular pace. Here I'm going slower so that the time between each rising edge is longer because I'm going slow. I'm going to start going faster. I'm going to continue going faster like this. You can imagine probably in practice running really fast. To see that, of course, we would zoom in with our time scale, but here I'm driving it by hand, so on. See that. So we can just count rising edges, or we count falling edges on channel A to keep track of our position. Now, the second thing, we've talked about this in class, of course, there's the direction. How do I know direction? Well, I'm going clockwise right now as I look down on it. And notice channel A is leading channel B. Whenever I get a rising edge on A on the top, I see I got a low on channel B. So that's clockwise. Now I'm going to go the opposite way. I'm going counterclockwise. Look, rising edge on A, I get a high edge on B. So channel A is lagging channel B. So we'll call that maybe negative, or it's up to you whether to call positive or negative. You got to decide for your setup. But here's one direction. Notice on the rising edge of A, I get a low on B. Now I'm going to go the other direction. Rising edge of A, I get a low on B. So I can do 3 things here. I can count edges coming in and keep track of my position. I can look at direction by checking the other channel, see if it's low or high. And then finally, I can measure the time between pulses to get a velocity. So I can do all 3 things. Now, quadrature would imply, if I can do this steady enough, you know what I'm going to do? Look at this. Okay, so quadrature would imply from this rising edge to that rising edge, I got 4 events that happen. Rising edge on A, rising edge on B, falling edge on A, falling edge on B. There's 4 events before I get my next rising edge on A. If I count every single one of those, that is 4, or quad. And the fact that we keep track of it, we call that quadrature. Hence the name quadrature. Sometimes people just say quadrature, sometimes the quadrature, incremental encoding, lots of names that go along with that. So we're going to now use some of the functions on our AVR processor to go ahead and just make in the background something that's keep track of our position and velocity. We can In this video, I'm going to make it a little short. I'm only going to capture rising edges A, so I'm actually only grabbing one out of the 4 pieces of information, but the idea is there, and you can make the encoder that you get 4 times as, 4 times as much resolution. Okay, so I don't know if you want to see me as a program. Maybe we'll start off with me as a program. Okay. So first thing we're going to do is look at our setup. So I've gone to our section of notes talking about external interrupts. I'm going to use the external interrupts to do the counting because then I can put most of the effort into the hardware of the AVR, the hardware watching for a rising edge. When that occurs, I'll increment or decrement depending on the state of the other channel. So I'll just really my code will be let the hardware see a rising edge. When it sees a rising edge, add to my count. I'll have a second activity. When I see a rising edge, I'll determine if I'm going forward or backward. And so I'll either add or subtract a count. That's really all there is to be done in software. And that, again, is in a hardware-driven interrupt. I can also have a second interrupt where I just am running a time. I can just keep track of some sort of time, and then I can use that time in my function to also calculate velocity. So that's what we're going to do. So here we are in the external interrupts in the AVR. We've got this nice little table here. We're going to use one of our nice dedicated interrupts. And I'm proposing we'll use interrupt 0, external interrupt 0, which is connected to PD0, or if you're using the Arduino EBB, it's on pin 21. And if you jumped over, you'll see that I've hooked up channel A to this guy. And then for fun, I hooked up channel B to PD1, and that would be on int1. In that case, I could have interrupts driving on either int0 or int1, but in this case, I'm just going to read. I'm not going to turn on the interrupt for channel B. I'm simply going to check the state of channel B when I see a rising edge on channel A. Okay, so that's the setup. You can see the registers I need down here, the external interrupt control register, A and B. For sense control bits, I'm going to capture on rising edges. So I'll just set that to 1, 1, and then finally I'll have to, since I'm using int0, I'll have to set an interrupt there. Okay. So here I have a nice, I've got the Arduino IDE open, and I'll start my programming. So I'm going to call this, I'm going to call it half. Actually, it's quarter quadrature. I'm calling it half quad encoding. Actually, it's I'll call it half quad encoder. So this program demonstrates use of external interrupts to perform. I don't perform quadrature encoding. And let's add a few little details. Let's see. We're going to have a channel A feeding into int0, which is PD0. We'll have channel B feeding into PD1. So I'm not saying int1 because I'm actually not going to turn on int1 for this example. I'll leave that up to you. Let's also set up we might go ahead and set up a real-time interrupt, a timer. I mentioned we want to do time, so let's do time on one of the real-time interrupts. So we're also going to track time. We're going to just have a time. So I'm just going to say track time, or I'm going to have a timer. I'm going to just have a timer, and I'm going to use a timer counter 1, and I'm going to use the timer overflow bit. So I'm going to choose to use normal mode operation. Hey guys, you're welcome to come on in. I'm just recording something here. You're welcome to hang out. I'm just 20 minutes, but you're not bothering me at all. Yeah, come on in. Okay, so I'm going to be in normal mode operation because I'm just using the timer, and I'm going to set my prescale to 8, which gives me a overflow time on this timer 1 counter of 0.0327668 seconds, and my timer settings, that clock scale select bits have to be 2 to 0, have to be 0 and 0. Okay, so I already looked in the notes and got that. Okay, I think those are pretty good comments. I'm going to make some global variables because I've been using global variables to pass information in and out of my interrupts. And I'm going to have basically two of them. I'm going to have a count, which is going to be an int. And I'm going to then have a couple and that's just going to keep track of rising edges for a rotation. We could come back and turn that into degrees, but I'm going to start with just counting that. And then I'm going to have a few floats. I need to have time as a variable. I'm going to have past time as a variable so I can keep track of time elapsed. I'm going to have a delta time. And from those, I can calculate a velocity if I choose. All right. Now I'm ready to go to my setup. First thing I'm going to set up is the external interrupt. Well, actually, first my I/O ports. So I'm going to say I'm using data direction register D, and I'm going to make them all inputs. So 7, 6, 5, 4, 3, 2, 1, 0. So all PD inputs. So that's 7 to 0 inputs. Getting a little redundant there, but all the pins on port D, 7 to 0 inputs. Next, I'm going to set up the external interrupts. So I've got to set up external interrupt control register A, and we're going to capture on a rising edge. We looked at that. So this is for channel 3, 2, 1, and then 0. It's going to be 1, 1. 8. Okay. So that's a rising edge on into 0. EICRA B is all zeros. No other interrupts. I need my mask. I'm going to enable my interrupt, and that's going to be enabling. So I'm going to enable int 0, the interrupt on int 0, and then finally, I like to do a mask or clear my mask. Clear flag, not clear the mask, excuse me, clear the flag on int 0. All right. Also, let's go ahead and set up our timer. So timer 1, and so that means we need to set up timer control register, timer control, or timer counter control register 1A, and it's just going to be 0, all zeros. It's a normal port operation, normal port operation, normal mode. Timer control register 1B. You have to, again, look at the registers and the notes. But now this guy got to set the CSC bits on the 3 least significant bits. So 0B, 76543. Okay, so 2 is 0, 1, and 0. So that's CSC is 2 to 0 is 0, 1, 0. I got to make that a comment, don't I? And then finally, let's see, well, I'm going to clear the flag first. Timer overflow register 1. I'm going to clear the flag on that timer 1. Yeah. So it's the least significant bit. So 7, 6, 5, 4, 3, 2, 1, 0. And I'm going to enable the mask. So timer mask 1 is 0B. 7, 6, 5, 4, 3, 2, 1, 0. So here I've cleared, and so that timer overflow flag is at the end. So I'm going to clear TOV flag, and here I'm going to enable timer overflow TOV enable interrupt. Okay. And then finally, in this case, I'm just going to print the results to the screen. So I'm going to set up my serial print. So I've got serial dot begin. I should just copy this over. Their initial, I'm setting my baud rate. Here I'm gonna while not serial So I'm just doing a wait setup, and then I'm just going to print serial dot print serial connection is ready. And finally, I'm going to just make a new line. Okay. There. That's what I have for my setup. Now in my main code, all I'm going to do is print my results to the screen. So let's do that here. So I'm going to print position is space, and then I'm going to be a little bit cheating. I'm going to just put this all in the same line. So I'm going to say position is, and then we're calling position count. And if we want, we can print the velocity as well, but we'll add that later. And then I'm going to have a new line. And so it doesn't print every time. I am using the Arduino delay. We need to set up and create our own delay. So I'm just going to create a half-second delay and create 5 second. So there's a little bit of a delay between my prints to the screen. Okay, so that's it for our code in terms of setup and loop. But there is where's everything happening? Remember, we're letting the hardware take care of that. So the hardware is going to issue 2 interrupts. The first interrupt we're going to issue is, let's talk about the interrupt service routine, or the external interrupt occurring on int 0. So we're going to create that guy first. So I'm going to say, and there's the function, which ISR, the interrupt servicing function, we need to give it the vector, which has been named. We've looked at that before, and since we're using int 0 vect. Okay, so what are we going to do inside here? Well, basically, we're going to index or decrement our count. So I can just do like count equal, I'll just say plus equal 1. Simple as that. Now, I want to check, is it a plus or minus 1? Well, I'm going to find out by checking the state of the other channel. So I guess I need to read that in. So I need to read in PD1. So I'm going to look at, so I'm going to read pin D. So if pin D, but I'm looking at channel. So maybe I could say something like this. If PD1 is high, increment count. Okay, that's what I'm trying to do. So I got to check PD1. So I'm going to take pin D, and I'm going to mask that with a mask that's going to have a 1 at PD1. So that's 7, 6, 5, 4, 3, 2, 1, 0. When I AND those two, I will get forcing everything where there's a 0 to be a 0, except at this PD1 location. If that is high, if it's 1, then it's high. So I'm going to check and see if it's equal to that. So I'm going to say 0B, 7, 6, 5, 4, 3, 2, 1, 0. And if it's low, it's not. So this will say if it's high, I put 2 parentheses there. I'm going to index count. And oops, let me go ahead and get my notation right. And if it's not, I'm going to say else. And in this case, my else is if PD1 is low, decrement count. So here I'm going to set count minus equal 1 and close up that. And then this is the ending of our interrupt service routine. And what's that? I don't know. Okay, there's the interrupt service routine. There we go. So that will now, on a rising edge, so this occurs, I can put that down, rising edge of PD0, which is int 0, just occurred. And so now I'm going to go ahead and increment or decrement count. Now, I haven't made my time vector yet, but this guy's done. So we could actually test this. Let's test this. So I'm going to go ahead and try compiling it. Oops. What do we call this? We called it half quad encoder. And a little error here. Try this again. Okay. Not too bad. I think I've got the serial monitor open. And this is crashing. Where I need to take a pause. Something's making the whole rascal reset. What have I done here? I'm somehow resetting myself. So let me just do a quick aside. Sure what I've done here. Let me try this again. Somehow something's making this reset every time. Just made this code, so I just copied the exact same thing. So let's try this one more time. Something is causing me to reset. Okay, hold on. I have to do something over on this program. Okay, well, I've got a gremlin in this program. Guess what? I just made this program, and rather than take your time to debug it, I'm just going to come back over to this. So this is what we just created. You can see our external interrupt 0, our timer, our serial, our print to the screen. The only difference is I have the time here. I actually created the time. So I went ahead and also had a little thing where I said, let's delta time equal time minus past time. I calculate the velocity is, since I just went one count divided by delta time, so that's my velocity, just roll it locally here. And then I update past time, so the next time I come in, I'll get whatever last time. And then the counts we just had. And then the timer overflow vector. Oh, wonder if it's because I never created that. I bet you it's because I opened up that timer overflow and then never created it. Yes. I'm pretty sure that's the problem. I thought I could get away with that. I couldn't. Okay. I just learned something there. Back to the code we just had. This is the code we had a minute ago. I turned on that timer, but I never executed it. And so for some reason, that was making a reset. All right, here we are. This is the code we had made originally. And you can see our position is running and our count is 0. So now, if you want to watch the screen, let's up over here. Sorry, I didn't. So, okay, so watch the position. I'm going to line up So you can see our position. I'm going to line everything up. I'm lining up this guy here. I'm going to restart my board. Okay. So now let me rotate to the right clockwise. I'm getting negative, so I guess my signage was off. I go to the left, I get positive. That looks good. I'm going to go back. Now, the first thing I like to do is I like to do a little check to see if it's kind of working. And so what I'm going to do is try to just start somewhere, move a little bit, and then come back and see if I get back to 0. And it looks like I am. So I'm getting good response. And go back to 0. So it's looking pretty good. I'm going to reset that one more time. And then I'm going to do a count and see. I'm going to do one full rotation as close as I can see that. Oops, I went past. That's about rotation. That's saying about 340 counts per rotation. I'm going to go back about a rotation. And I get almost to 0. I think that's about as close as I can just eyeball line it up. So I feel like this encoder is working pretty well. I'm going to go 2 rotations. It was about 340, should be about 680, thereabout. I'll go negative 2 rotations, or I guess positive 2 rotations. Should be back to 0, almost to 0. Okay. And one last time, this is running in the background of your processor, so you're free to put whatever code you want in your loop, and you're just tracking your encoder anytime. Actually, we got our stuff. Yeah, this is our stuff. Got it to work. This is just running in the background. Again, I was crashing because I had not created that program. This timer not being here for some reason was causing this chip to reset every time. That's a little lesson learned. If you turn on enable and interrupt, you need to have an interrupt service routine, I guess, even an empty one. Okay, fun demo, fun exercise. I'm going to wrap up with that. Thanks for your time and attention, and I'll see you in the next video.